Hello, I'm Cody Whipple with the Pennsylvania Fish and Boat Commission. Today, we're in Union County, Pennsylvania on a stream that's locally known as Bull Run. Now on a map, it can come up as Limestone Run as well. This stream is in a fairly urbanized area. If you look off to my right here, you'll notice that we have a playground. We also have a parking lot. Off to the left, we have a very heavily used road. You'll hear some traffic going by as we're actually filming this video. So this is the same stream that we were on. In a previous video, we showed you some of the factors that contribute to non-point source pollution. Today, we're joined by two very special guests, Renee Carey with the Northcentral Pennsylvania Conservancy and Shannon Stamm with the Union County Conservation Districts. They're gonna go over a project that was recently completed on this stream. They're gonna talk about the planning process, sort of the partnerships that had to come together to make this project happen, and Shannon's going to go over some of the habitat structures and some of the structures that they place within the stream to help mitigate those factors that we talked about with non-point source pollution.
Thanks, Cody. So my name is Renee Carey. I work for the Northcentral Pennsylvania Conservancy. We're a regional land trust based in Williamsport, and what we do with the North Central Stream Partnership is we work with all the county conservation districts, some of Cody's colleagues in the Stream Habitat Division of the Pennsylvania Fish and Boat Commission, and the Department of Environmental Protection, and private landowners. And so when landowners have problems with their stream banks, a lot of times they reach out to their county conservation district for help. And so Shannon and the people in other districts like Shannon work with the landowners to find some solutions. We work with the Pennsylvania Fish and Boat Commission to actually design the projects and get the permits, and then DEP helps provide the funding. So Cody's mentioned in other videos that we're in the Chesapeake Bay watershed, and that the sediment entering the Chesapeake Bay through the Susquehanna River and the West Branch Susquehanna River is a problem for the people in our region, but also people downstream from us. So we have funding to help us stop sediment from entering streams. It helps keep local streams clear so folks can swim and fish, but it also helps the Chesapeake Bay. So some of the things we talk about when we're talking about a project is how far up in the watershed we are. We like to work in the headwaters downstream so that those improvements are seen the whole way down the watershed. We also talk about how close projects are, because Shannon will be showing you structures that are built with logs and rocks, and we have to get those logs and rocks places. And a lot of times, if we can have the guy who's driving the log truck drop logs at a couple of different sites, it saves us money. And if we save money on one project, that gives us more money to spend on another project. But I'm gonna turn it over to Shannon, who is actually already in the stream, so you can see the stream and what we've already done. Thanks, Renee.
So as we said, we are about 100 meters downstream of where we talked about the impaired section of the stream with the U-shaped channel that we had. Again, we are in an urbanized area. We are pretty far down in the watershed. We're near the confluence with the West Branch of the Susquehanna River. We have a lot of infrastructure. So there are certain factors we want to take into consideration when we're designing these structures. As Renee had mentioned, just the logistics of getting the materials to the site is one of the factors that we have to look at. But when we're looking at designing the stream, we're looking at some of the characteristics of the stream. Is it channelized? And in this case, it was. We've got that U-shaped channelization going on. We want our banks to be sloped back to allow water to gradually rise up those slopes and get out. So as we've talked before, easy in, easy out for the water. We don't want to create any erosive forces. In this section, because it is in that U-shaped channel and the stream cannot get out to relieve its energy, we keep getting wider and wider and ending up with more of that siltation. So that was what we wanted to correct at this site. So as we're walking upstream, you can see some of the structures that we put in are meant to help narrow the stream back up in areas, because again, we said we were over widened. The other thing that this structure will do is it will actually trap sediment on the upstream side. So the sediment that is still coming down the stream will be captured at these locations and actually grow the bank back out for us over time. So you can see where the original stream bank was located back in here. We now have root structure along here. When we first came in here, this was a completely open stream. It had no canopy, no trees whatsoever. It was mowed right to the edge just like it was upstream. So in 10 years time, this is all filled in using this multi-log vein deflector. So it captures that sediment, it helps stabilize the stream bank, but that's only one component. We also need the trees to add to that component. And you can see over time how these trees have grown on our structures, and then eventually it will grow out to the tips of these, and they'll actually be hidden in here. You almost don't even know there was ever a project done. So it's working really well to capture that sediment that we still have coming from upstream. It also will scour a pocket at the tips of these log structures so that you can create more habitat for the fish. As you've noticed, I'm a little deeper than 2 inches of water. And as we go upstream, you're gonna see we actually have a thalweg where I can find a channel within the stream now, and we have different habitats. So that scour at the tip will help create some oxygenation, but it'll also create a pool at the tip of that, so we have different habitat on the downstream side of that. But again, this is another good example of this log structure doing its job, and you can see how much sediment it has captured in the 10 years that it's been here. Streams will always erode. Streams migrate. Streams want to move. It is a natural process to move sediment. However, in these unnatural situations that have been created, in this case, the stream was straightened years ago, and being over widened, it's not going to be able to correct itself. So again, these structures help do that. The plantings help do that. And in this case, we actually have some native willows here that were planted in this area that we can actually even, these can be used, and this would be done with tools. I understand this isn't necessarily what you want to be doing with this, but we can use these native materials as live stake materials, and we can actually plant these into the stream banks. I don't know if I'll be able to get one in here, but you can actually jam these into the stream banks and they will grow. So it's one of the methods that we've used as a cheaper alternative. We like to try to pool all the resources we can when we are trying to do these projects so we can be more cost effective and get more stream miles done. So we will use live stakes. And there's actually the local conservancy, Chesapeake Conservancy, has actually been using students at Susquehanna University to harvest these live stakes and actually get them out to some of our partners to be used on project sites like this. So as we're walking upstream, we just walked through a deeper area in the center of the stream. Now we're actually rising up out of that pool. We have the log structures again. We usually put them on opposing sides in these over widened areas to help narrow the stream back up and clean up the substrate. It helps flush the system back at its normal widths, the normal flushing that would be created in a stream, in a natural stream system. And where that happens, you can actually see that we have a mixture of different substrates in here. I know it's kind of hard to see right now, but we've unearthed larger rocks. We've got the smaller rocks. So we actually have, we've got the little pebbles, we have sizes that are in between. So as you can see out there, the flushing that this did within the center of the stream and how much cleaner the bottom is, which is obviously important for the macroinvertebrates and the fish community that lives in here. So a lot of this was taken care of with those single log veins or multi-log veins. We have some mud sills in here, but not as many because we didn't necessarily have the deep water to put that type of structure there. What we do have here is a log cross vein. And so this log cross vein keeps the water, keeps the energy of the water centered within the stream channel. It creates a nice scour pool on the downstream side. You still have the wing logs that will trap the sediment on the upstream side. And it creates really nice, deep, oxygenated water for downstream. The other things these log structures do actually is we can create leaf packs on the upstream side of some of these. Again, we have the slack water area over here that a fish can rest or use otherwise. Getting off subject. What else, guys?
You hit everything.